Well, thank you for the introduction, Adrian, and good evening, everyone. It's wonderful to see so many people here. Give you a quick background on the STBA, Sustainable Traditional Buildings and Alliance. So we are independent. We have no axe to grind and no commercial interest whatsoever. What we're really interested in is making sure that we've got a decent and beautiful building stock to bequeath to the next generation. What I call genuine sustainability. So in order to figure out what we do with our old buildings, we have to have three basic kinds of thinking in play. We need to know about heritage, we need to know about sustainability, and we need to have industry on board. So the Alliance itself is comprised of members drawn from all those three backgrounds. And I'm sure you'll recognise a lot of the logos on this page, but they certainly include all the major heritage bodies in the country and everyone that you would expect to see from industry, RICS, REBA, the Construction Industry Training Board, etc. So I won't dwell on this. Before getting into what we can do to improve our building stock and ways of managing risk, very important that we don't compromise that. And I'll come back to ventilation. If you get this wrong, if you seal up a building and you stop it breathing, then you get what we call composting building syndrome. And here's a fine example of it. And that's within a couple of years of poorly applied solid wall insulation. Basically, moisture plus heat plus organic material equals compost. That's what we're up against, folks. Not only that, we've got our friend the dust mite, and if you push moisture levels beyond a certain level, their rate of reproduction increases exponentially. So that and mold growth, we've got a lot to contend with. There's a very good mnemonic, if you like, no insulation without ventilations, based on the American Constitution, no taxation without representation. It is terribly important when we start insulating buildings that we check the ventilation. Otherwise, we get poor indoor air quality. By sealing up floors, roofs, windows, we compromise this natural ventilation, which is so critical to old buildings. Now, I know this is not a national park photograph, so with apologies if you haven't got any terraced buildings within your national park, but I suspect you have. This is how to get it wrong in a heritage sense, because heritage is a shared resource. And by insulating that one building, you've lost the brick banding, you've lost the oversailing courses. And you also have to ask yourself, really, how much energy has been saved by putting that external wall insulation on that particular building? Because there's a lot of window on that front elevation and quite a bit of door as well. And then you've got the rest of the building with its other heat losses. So in order to just satisfy the desire to insulate walls, I fear in this case we've done more good than more harm than good. So those are the kinds of things we're up against. In the Yorkshire Dales, I guess your issue would be more, do you want to cover up this wonderful stone building? It's really very, very difficult to insulate such buildings internally because you're usually limited with floor space. And there are restrictions in terms of moisture movement. If you make a wall too cold by stopping the heat running into it, i.e. by using internal wall insulation, you reduce the ability of that wall to dry out. In other words, it needs a certain amount of heat running through it from the inside to the out in order to stay dry, because water will penetrate that skin. And a lot of the buildings you're looking at in the national parks are going to be exposed. They are going to ship a certain amount of water. So insulating them on the inside, in most cases, isn't really an option. And if you do pursue it, really only in a limited way. So that's getting it wrong. What about getting it right? What can we, where do we go? Well, first of all, I would stress the importance of context. We also need to think about maintenance and repair. That is the poor relation of the retrofit industry. Nobody talks about maintenance and repair. We need a people-first approach and not a fabric-first approach. And most importantly of all, and if you take anything home with you this evening after today's talk, sustainability is about more than just carbon emissions in use, and that's a drum I frequently bang. So you put it all together and you are not just talking about energy, you're also talking about building health, you're talking about heritage and the community. So all these things need to come together to produce a holistic approach. In terms of an individual building, the left-hand part of this graphic is people, its services, and its building fabric. You need all three working in tandem. You then add those context elements, which includes the location, and you can see exposure is written there. That's terribly important. A lot of the buildings you'll be looking at. Also the regulatory climate of the time, whatever grants might possibly be available, lifestyle issues, all these things are part of context. You know, people didn't used to take a shower every single day. Some still don't. You know, once a week, once a month, our lifestyles have changed. Our approach to using buildings has changed. But we need to put all these things together to get what we call a whole building approach. On the positive side, there was an Each Home Counts report sponsored by the government, released in 2016, and that took up this whole building approach that the STBA and some others had been arguing for. That led to a call for new standards, and in 2019, PAS 2035, which is the new standard for domestic retrofits, was published. And that also takes very much a whole building approach. In Wales, they're ahead of the game. They've got what they call the Wellbeing of Future Generations Act, and that obliges the government to take a much more rounded approach to all new policy. And therefore, they can't just get away with a kind of single measure, just carbon dioxide emissions from a building in use. They've got to take a more rounded approach. We need health, we need heritage, we need embodied energy in there as well. All these things are important. Otherwise, you'll end up creating more carbon emissions than you save. STBA published a little paper quite a few years ago now, and certainly well before the Each Home Counts report, called "What is Whole House Retrofit?" And you know, you can look at it in different ways. There's a very, very basic approach, which is just looking at the U values of individual building elements, so improving the U value of a wall or of the roof and so forth. But that doesn't really address all the questions about air tightness or about thermal bridging between a wall and, let's say, a floor. So, you know, if you insulate the wall but don't do anything with the floor, you can get a cold spot at that point, or vice versa. And you may start to get, thanks to thermal bridging, you may start to get condensation, damp and mold appearing in places where you didn't have it before. So the next one up from there is Whole House Plus, where you integrate all the services and ventilation and behaviour. But that only gets us so far. Really, where I want to get people to, and I will come back to it right at the end of this presentation, is what we call Whole House Advanced, where we add in the community context as well. So free download that paper from the STBA website. So where are we actually going in terms of risk? Most problems in retrofit occur not in individual building elements, wall, floor, roof, etc., but at the interfaces between these elements or between elements and different technologies. Now, a lot of these effects are not fully understood. We don't really understand how a lot of buildings behave, let alone how they behave when we start making changes to them. And then it's going to be different depending on how you occupy the building, and even economic context can change it as well. Very good example of this: when you make one part of the building warmer, you make another part relatively cooler. Now, if you insulate the back wall of a property but leave the front, because it's very difficult to insulate for perhaps for heritage reasons, and you don't do anything at all with the moisture movement through that house, you've actually made it more likely for condensation to occur on the front elevation, on the inside of the front elevation. So you've done something to the back, but you've got suddenly a problem at the front that you didn't have before. These are the kinds of issues that we're up against. Maintenance is never mentioned at all in the whole retrofit debate, but as we all know, a dry wall is much more efficient thermally than a wet wall. A wet wall just conducts heat fast. Water is very good at transferring energy out of the building. To say nothing of health, etc. We must maintain buildings in the way that they were designed originally to function. And that I think is a critical method, but it's a message. But it's kind of not sexy. It doesn't mean spending loads of money and putting in lots of new whizzy technology. No, just fix the building. So, what can we start to do? By the way, this is what I guess you would call a kind of a building with air tightness challenges currently. One in Yorkshire, I believe. We can look at these different aspects of fabric, and then we can look at these different aspects of services, including ventilation, of course, and we also need to look at the interaction with the occupants. There isn't enough time tonight to go through measures for every single one of these. So I'm just going to give you one or two examples. And looking at a roof, okay, we know that we can insulate lofts reasonably effectively, but it is absolutely critical to maintain ventilation at the eaves. We have found in a number of properties, if you don't maintain that ventilation at the eaves, you start to get condensation forming on the undersides of rafters, and then you get composting building syndrome. So absolutely critical when you are insulating a loft to use some form of eaves ventilator. Windows. I mean, that is a lovely section through a sash window. This is slow-grown Baltic pine, absolutely beautiful stuff. It smells, when you cut it, it still smells the way it would have done when the tree was first cut. Those windows often had, well, they all did originally have rolled glass rather than float glass, and that has wonderful imperfections in it that really give a building character. Those windows had the correct proportions, and they were easily repairable. And there's a lot of craftsmanship gone into those. There is, I think, a great loss that as a society we've experienced thanks to indiscriminate replacement of really very good functioning sash windows. And there were plenty of things that we could have done to improve those windows. And we've put together the STBA a number of decision trees for different types of fabric intervention. So this is just one example. This is windows. Do you already have double glazing? Well, if you do, is it good double glazing? Is it got a decent air gap? Or is it really very early double glazing, which actually still conducts heat quite quickly? And you can go through this decision tree. I'm not going to go through it in detail right now, but you can come to some solutions, which might just be to repair. They might be to repair and add secondary glazing. They might be to do those two things and add draft proofing, or perhaps reinstate your shutters if you've got them, or just heavy curtains if you haven't, because heavy curtains and good draft proofing will do, and secondary glazing will do most of the work of window replacement in thermal terms. Secondary glazing systems have got much better in recent years. And looking at that window, you really can't tell that it's been secondary glazed. It retains the original frames, and just as importantly from the outside as well as the inside, it retains the original glazing. And overall, you're getting perhaps 75% of the benefit, but you're doing this at a fraction of the embodied energy of ripping out those beautiful windows and replacing them with something else. So that's certainly something which you might have written off as an approach 10 years ago, but we're getting very good at this now. The same with ground floors. Is it solid? Is it suspended? If it is suspended, you can, I don't know, insert a small child from underneath and ask them to do the work for you. If you haven't got a willing child, you may have to take up the floor and insulate it from above. If you're lucky enough to have a cellar below and good access, absolutely fantastic. But a crawl space is normally all you're going to get. So a lot of challenges with floor insulation and solid ones. I'm afraid a lot of the time is just leave it where it is, and given the embodied energy of ripping up a floor, the solution may very well be to put a carpet down with a good underlay, or solid flooring with a decent thermal underlay. That, in overall embodied energy terms, is probably going to be your best bet with solid floors. Digging them out is a major issue. What about walls? This is a terrace in my hometown in Harborne, in Birmingham. They insulate the external walls of that terrace over my dead body. I love it. It's got a rhythm. It's got a real beauty to it in many ways. So there are many things you can do, and it depends very much on what you've got. That top picture, well, those walls have already been rendered. By taking off that render and putting on an insulated render, you're not substantially going to change the appearance of those buildings. The insulation might be a little bit thicker, but worst case scenario, you might have to extend the eaves a little. And it is doable here. You've got a tiny gap above the windows. Sometimes you haven't. So on the top picture, I'd say, yeah, okay, maybe go ahead and do that. The bottom right, obviously not. The one on the left of your picture, well, that's more difficult. That's a Scottish tenement, as I recall. And there are certainly some government-funded projects around at the moment, or government-backed, I should say, to insulate such buildings externally. But it doesn't have quite the kind of delicacy of some other buildings. It's a nuanced thing. It's difficult. Take a building that's already been rendered, the render's been removed, there's a lot of damage to those bricks, you can't really see far off. But they're using a breathable system here. That is a wood fibre board which has been attached to that building on the outside. It'll then be rendered afterwards. And the great thing, of course, about wood fibre is that it is vapour open, and the render which is applied afterwards will be a lime render. It's a lime built building, so that will also remain vapour open, i.e. any build-up of water inside the property or inside the wall matrix is allowed to escape both inside and out. Walls breathe, I should say, in both directions. A word about thermal bridging, which I think is an important consideration. Most commonly occurs at the junction between a flat ceiling and a wall if it's been insulated externally. It's a difficult detail to get right, and this is why it's so essential to extend the eaves, is you can actually produce a junction between these two types of insulation. If you don't do that, you tend to get condensation forming at that top part of the wall, and people often say, well, why is this? Nothing else seems to have changed internally, but of course you've got a cold spot there, and the moisture that used to perhaps condense elsewhere has got nowhere to go. Sorry, the thing has skipped forward a bit. So thermal bridging, that's what it is. Some more horror show, how not to do it. This is in Wales, as I recall, on some social housing. Really, they need to do something else with the gas box, not trying to work around there, because they've just created a huge thermal bridge. And on the other picture, you've got a lamppost, and they had to insulate around the lamppost. You get these kind of crackers things in retrofit all the time. Sorry about this. My mouse is jumping. You get it all the time, and it's really about bad planning and a lack of architectural design, and we do need the architects involved. Internal wall insulation, yes, you can do it. There's going to be a loss to floor space. You've got to use moisture open materials, and a great deal of care is going to be needed at the reveals, i.e. junctions between walls and windows and doors. And you may need to use a super thin insulation, something like an aerogel product to get around the problem of the reveal. Otherwise you get condensation at the reveal. It's the one time to use a really, really high performance, super expensive insulation. There are also limits to how far you can go with internal wall insulation because of what we call the dew point temperature. Sorry to get techie on you. But if you get this wrong, if you put too much insulation on the inside of a wall, you can cause condensation to happen within the wall matrix, and it usually happens at the junction between the insulation and the wall. And the place where you didn't get a problem before suddenly gets wet, and invisibly, because it's behind the insulation, you get mold growth, and that ultimately can harm human health. So come back to what I said at the start about retrofit needing to have that human component. Just for once, and this is quite unusual to hear a builder say this, the building regulations are our friend at the moment. L1B, which is the domestic existing part of the thermal regulations, has what's commonly called an exemption, but it's really special considerations clause. It's 3.8 to 3.10. It's a free download, again, from government websites. And it mentions in these various categories of building where these special considerations apply, it mentions buildings of traditional construction. So that is going to be all the old buildings that you have in national parks, be they stone, be they brick, in fact, be they timber frame for that matter, but I think largely stone. So they're built with lime mortar. So they're permeable fabric that readily allows the evaporation of moisture. Now, in that case, in those buildings, they have this exemption that when undertaking work, the aim should be to improve energy efficiency as far as is reasonably practical. Now, this is very important because it gives you some ammunition if dealing with the building inspector. Say, no, actually, we don't need to meet the minimum U values set out in the other parts of the Part L of the building regulations, because it's a building of traditional construction, permeable fabric, it's vapor open. We just need to do what is practicable, what is safe. However, there is a proposal afoot, and there was a consultation last year to change Part L. So the only exemption will be one of, in terms of moisture risk, we lose the exemption for traditional buildings in terms of their character, the character of the host building. And that is a very important change and proposed change. And we need to get onto that and make sure it doesn't get too much traction. Whether it was deliberate or not, I don't know, but it's a bit of a charter for the insulation companies to get out of that very important exemption for traditional buildings that's been there for a long time, since 2010. The STBA itself has got loads of free guidance which you can find online. Moisture risk assessment. The guide to solid wall insulation that we did for Bristol has got a whole explanation in it of the kind of whole house approach, and it's worth it just for that. What is whole house retrofit, I've alluded to, and a 24-page guide. It's a very good place to start if you want to get into our thinking, called Planning a Responsible Retrofit of Traditional Buildings. And about 2014 or 15, I think, we released something called the Guidance Wheel, which you can see an image of, which is a fantastic piece of software. Adrian was involved with, very much involved with the development of this, and it's still really one of the finest things I think STBA has produced. It's really a guide to decision making. The 24-page guide I've just mentioned, it's all got all kinds of good stuff on risk assessment and risk management. And importantly, in that diagram, you've got the feedback loop there. We have to be honest about our mistakes and learn from them. And that's something that we've not been very good at in retrofit. There've been some terrible things gone wrong, and we haven't been very public about it. And the STBA does try to collect and share that information. So, for example, in that guide, it tells you what the risks of EWI, IWI, roof, loft insulation are, tells you how to manage those risks. That's the kind of information that you'll find in that guide. I mentioned that there had been a new standard for retrofit, which came out in 2019. And this really marks a sea change in how we approach retrofit in this country. Because among its aims, it starts with functionality, usability, and durability. It mentions comfort, health, and well-being. This is this is really revolutionary stuff for a standard that's got to do with energy efficiency. And amazingly, it also talks about the enhancement of architectural and cultural heritage as represented by the building stock. So to get these things actually thought about when planning retrofit is a major success. Now, all publicly funded projects have to use this new standard, but it's of course voluntary for other schemes to use. And I would really suggest that whatever strategies you develop for the national parks are based on the principles, the aims, if you like, of PAS 2035. It really is a useful document. It's very heavy on process. The idea is to avoid the one-size-fits-all approach. It absolutely relies on survey. Every building is different. Sorry, come forward again. And means that we've got to treat every building with respect and to develop an individual plan for each building. We can't just say that, well, what works in one place will work in another. Even location can change how you decide to approach a retrofit plan. The guidance wheel itself, it's a freely available online tool. If you simply Google STBA guidance wheel, it will take you to a website called Responsible Retrofit, where you should be able to access it. If we had a little more time, I would actually demonstrate it for you online. So I'm going to whiz through the slides which are here, but it's an aid to decision making. And what it does, having selected the context and selected a particular measure, in this case we've selected secondary glazing, the arrows provide links to other aspects of building fabric and services that you need to think about. Each of those arrows has got an explanation attaching to it. There are technical concerns, and all the things you see on the right-hand side of the screen open up with those arrows, drop down into menus, which give you a great deal of information about what those particular concerns are, whether they're heritage, energy, or technical concerns. And all of this is backed by published peer-reviewed research. And that itself is accessible through this tool. Excuse me. So, if you've selected external wall insulation, it'll tell you that the technical concerns relate to ventilation and to moisture risk and to thermal bridging, which we've touched on, and indeed to overheating. That can be a problem with some retrofitted buildings. And of course, in terms of heritage, we have a change of appearance, a loss of detail, and ultimately a risk of damage to the fabric. So those are the sorts of things that are flagged up by the guidance wheel. I'm whizzing through this because I want to tell you about some guidance from other people. Historic England have put out some great guidance on old buildings, including specific guides to dealing with particular building elements, be it a roof or a floor and so forth. But their overall guides are addressing process and addressing the principles of retrofitting old buildings are also very good. So I commend Historic England to you for sources of further information. There's also the UK Centre for Moisture in Buildings, which was founded by a late colleague of ours, Neil May, from the STBA. Again, Adrian worked very closely with Neil. And we've kind of handed over the expertise, if you like, in moisture in buildings to them. So they are now the kind of UK heads of this. I'm sure you've all heard of EPCs. A lot of you have probably got them. I'm afraid I take rather a dim view of EPCs. They simply can't align with the whole house approach. I mean, they can provide a useful part of it, but they can't deliver it. There's nothing on condition, context of any kind, really. Moisture, ventilation, heritage significance is completely excluded from an EPC. And I call it yesterday's metric for yesterday's agenda, and I stand by that. The other thing that we're trying to say instead is you've got to take a whole house approach, or if it's a non-domestic building, a whole building approach. And that will ensure that every building becomes as sustainable as it can be. I mean, there's a lot of buildings that you just can't make them perform like modern buildings. We have to say, well, they weren't designed that way. They were designed to be sailed in a different manner. But a whole house approach will instead ensure that we avoid a lot of the unintended consequences that I'm afraid we've been subject to. And just as importantly, it can deliver a whole range of co-benefits to the local economy and to the environment and to residents. So we did quite a detailed paper exploring what could be done about EPCs. So that's another download if you want it. And I said right early on when we were looking at the different levels of whole house retrofit that there was this whole house advanced. Now that kind of morphs into what I am now describing as a regeneration agenda. And if we're going to spend an awful lot of money and an awful lot of effort changing our building stock to accommodate the needs of the 21st century and to address environmental issues, including climate change, but also including resource depletion, also including pollution of different kinds, and to keep in mind, of course, heritage and health. We can go further. We can provide local employment. We can not just do a retrofit to a few buildings, but we can start to regreen the environment. We can clean up the legacy of the industrial revolution, which we still really never managed to do in the 20th century. Yes, we'll do energy efficiency, but let's do water efficiency as well. And while we're about it, let's do sustainable drainage and provide some local facilities. We can get smart with our local energy networks. Energy, like everything else, has economies of scale. So, it's better done at scale. And we can start to introduce recycling, car sharing, garden sharing. I'm beginning to sound like an old hippie. Yes, I know, but that's kind of what I am. So bad luck. In the midst of all this, you can get some community-led decision making. That's really where I think this is leading. We need genuine localism to deliver a regeneration agenda. But most importantly, what that does is to eliminate the conflict between heritage and sustainability. So if you've got a genuine approach to sustainability, that it will incorporate heritage because it's going to be part of the tomorrow that you want to leave to the next generation. So we have to, and this is my last slide, I think, we have to ask ourselves what it is we're really trying to achieve when we retrofit buildings. Are we trying to get carbon emissions reductions in use at any cost? Or are we trying to deliver a sustainable future? And if we do that, we take a regeneration approach, and that delivers health and comfort, delivers improved appearance. It's not just spreading white porridge all over our old buildings. We use sustainable materials. We use local materials wherever possible. We also think about ecology and replanting and public transport. All these aspects of regeneration. If you just take a narrow carbon dioxide approach to retrofit of individual buildings, you miss all this. You miss the local economy, the jobs, the maintenance and repair. And of course, the best way to deal with fuel poverty is to deal with poverty and get the long-term unemployed back into work. And there are great opportunities in a regeneration approach to do just that. So that, I think, in a nutshell, is what we're all about. And I'm very, very open to questions. I'm not sure I can see them all, so I'm going to hand back to the chair